We're going to be going a little wide, but not very deep on OpenStack today. It is a big project. It is definitely the most difficult up until OpenShift project that I've worked with. And it's what makes it so difficult is there's a lot of moving pieces, which is the same for OpenShift too. What is OpenStack? OpenStack lets you turn a pile of hardware into a cloud. And that cloud can be public, private, however you want to do it. It is an open source project. It was started by NASA, a joint effort between NASA and Rackspace. They got to working together. They were looking to do private clouds and public clouds if you wanted to do it that way. NASA provided the first code for virtual machine management. I can't remember the name of their project before it came into OpenStack, but I think it's like Neutron or something like that. I can't remember, to be honest. But it became Nova, which manages the actual virtual machines inside of OpenStack. The piece that Rackspace initially provided was, they called it Cloud Files, I think, something like that. And it became Swift, which is the OpenStack analog to Amazon S3, so object storage that you can access via HTTP. Everybody knows what cloud is. Infrastructure as a service, some of you probably know what that is. Basically, what you're doing is providing people access to hardware or virtual machines, compute, storage, network, stuff like that. But that end customer is not responsible for the actual systems that run those functions. Here's a brief history of OpenStack. Started all the way back in 2008. It started getting really big around the Icehouse release, 2014. That's when a lot of people were talking about it. Some of the CERN stuff, I don't know if you guys have ever watched CERN or looked up CERN stuff. Thank you, Gary. Nebula, not Neutron. CERN's got some really awesome stuff, and they actually blog quite a bit about their OpenStack. They have a massive infrastructure. I've seen a couple of their presentations at the OpenStack Summit, and those guys they know exactly what they're doing. Last couple of years, you've heard probably about 5G. Verizon specifically is who Red Hat is working with, but a lot of people are, a lot of the telcos are using using OpenStack for their back-end NFV, network function virtualization. Get onto that in a second. Yep, there you go. NFV, the network function virtualization, science and research. That's where I started using OpenStack. We managed clusters by hand before OpenStack, and it was a world of difference. Then service providers, think of service providers as people like DigitalOcean or the non-Amazon, and you can count Amazon in there too, but they don't use OpenStack. There's VexHost, VXXHOST, I think is another big public OpenStack provider. NFV, basically what this is, they're using OpenStack to provide virtual functions, network virtual functions, to their network. And what's a network virtual function? That's things like firewalls, load balancers. It could be anything, LDAP directory, anything basically that gets spun up in software to imitate some function that we used to think of mostly as hardware. And the people who interact or services who interact with those functions do not realize that it is virtual. Science and research. The big thing here for us was basically managing a large pool of hardware exactly like we would manage our virtual machines. It is very awesome to be able to run one API call and change one setting or toggle one bit inside that API call and spin up a virtual machine or spin up a bare metal machine. That's the way we took advantage of it. But we also used it to be able to quickly adapt our HPC clusters. So if we had somebody who needed to run a large Hadoop workflow, we had the bare metal nodes tear down and rebuild themselves for Hadoop. Compared to the normal generic research, just general compute that they spent most of their time in. That's one example. Another example is we had some container workflow that people like to have, and we would do something similar with that, where we would tear down the node and build it back up as a container node, and they could run their containers on that node. Service providers, like I mentioned before, VexHost is an example. There are a bunch of them out there. You can go out to the OpenStack website and see a list of all of them. But they're using OpenStack to provide cloud offerings for public, just like AWS or Microsoft or whoever else, Google. What can OpenStack do? Here's a little bit outdated graph, map, whatever you want to call it. There are, I think right now, 44 different services that are included in the main OpenStack. Here's most of them. It gets broken out into what each thing is, what product each is offering. We have storage, compute, networking, hardware lifecycle, which is bare metal, like I was talking about, accelerators like GPUs. Get all your shared services, Keystone placement. I'll touch all these. There's a million of them now. There's a base set that like you kind of want to have, the 5 or 6. Keystone, Nova, Glance. Those are the main ones. Neutron and Cinder being the other two. Neutron's the network service, Cinder being the block storage service. Keystone, this is the most important service. It basically is your auth in and auth z service. So it provides authentication and authorization. And all services, it's also a list of API endpoint management. So if you need to find what API is where, like say you wanted to talk to Neutron, you could ask Keystone to give you a list of all the Neutron endpoints, and he'll give you back, all right, it can be accessed at these URLs. And tied into other backends, AD, LDAP, all that. It's pretty awesome. It makes single pane of glass a little bit easier to manage. Networking is the Neutron project. Neutron is not SDN. Neutron is just, it is the API wrapper around whatever SDN you're going to be using. By default, Open vSwitch is the SDN in OpenStack. And if you're familiar with OpenShift, the same Open vSwitch that runs networking there. You can tie Neutron into other SDN solutions. Big Switch is one that was fairly popular. It's kind of fallen out now. Juniper, Arista networks, you can tie into those switches. Basically, you just provide a plug-in driver to Neutron, and that allows Neutron to actually talk to the switches themselves and do things like create VLANs, isolate tenants that way. It gets pretty wild. It is really impressive, but it's also really finicky, my experience. Open
I
vSwitch
recommend
is
staying away from Big Switch.
say it one more time. I'm sorry.
I recommend staying away from Big Switch. I've seen it in
Oh
action.
yeah.
It wasn't fun.
Yep. Yep. When it works, it's awesome, but it's kind of a coin flip if it's going to work in my experience.
They dragged their feet too long on certifying
Yep.
drivers.
Yes. Yeah. And that is a big problem with a lot of the network drivers. Juniper is another big one. Contrail, which is not called Contrail anymore. I can't even remember the name that they changed it. Tungsten, I think maybe. It's the same boat. There's another one starts with an M. Midonet, Midonet. We looked at that one. It's very similar. They can't keep up with OpenStack's release cycle. OpenStack, let me jump back and mention that real quick. OpenStack does a release very much like Ubuntu and Fedora every 6 months. So you'll have one in the spring and then one in the fall. And they have got it hammered out really well that they make those releases. And it is very easy to fall behind if you don't have a team of developers dedicated to it. Glance is your image service. This is you download a cloud image, you upload it into Glance, and Glance will make that available to your projects or tenants. It supports many formats. A cool little trick about about Glance. You don't have to give it a image. You can give it anything. You can give it a binary. You can basically cheat and use it as storage. Glance doesn't check what you're giving it. It just says, oh, you want me to hold some bits for you? Cool. I'll hold some bits. They're images or not, it doesn't care. That's a way to. And actually, OpenShift has recently started using this in OpenStack deployments. If you're deploying OpenShift on OpenStack, it will store the plans that tell the nodes how to build themselves. I can't think the name's slipping me. Somebody will have to tell me. But anyway, they take advantage of that. Nova is the compute. This drives the VMs, managing where they land, where they live, what hypervisor they land on when you spin a new one up. The scheduling does API to talk to them. It talks to other services like Neutron and Cinder for like what network your VM is going to live on, what disk it's going to attach to, that sort of thing. Supports a lot of different hypervisors. KVM is the default out of the box. Also, when you're using Ironic, which is next. Ironic actually is a driver, acts like a driver for Nova. So you're still talking to Nova when you spin up a bare metal node, but Nova says, oh, wait, this is a special kind of VM that I'm spinning up, so let me talk to the Ironic service. The way Ironic manages hardware is through IPMI or a vendor-specific version of IPMI like iDRAC or ILO. Redfish is the new thing. I don't know if you guys have heard about Redfish yet. Basically, think of Redfish as the EFI of network booting. They are doing some really awesome things with Redfish where you can really take advantage of the advanced features of your ILO or iDRAC or whatever. Really nice. Heat is your orchestration tool. It is like CloudFormation in AWS. You give it a YAML template and it'll go build something for you. What that something can be as simple or as complex as you want. But it's pretty awesome. One of the Big features of heat templates is setting up auto scale groups for your for whatever web servers mostly, so that they will grow out as load increases, just like in AWS CloudFormation. The Horizon dashboard. Basically, this gives you a GUI to talk with OpenStack. It's actually a really good GUI. It's one of the better GUIs that I've ever seen for how thorough it includes every option that you want to use for OpenStack. Back when when this got introduced, they had to. This is a secondhand story. It may not be true, but it was told to me by somebody from Rackspace. Horizon was so awesome of a GUI that they had to make a stipulation in their certification for their certification tests that you had to do things with the command line, certain things with the command line, to pass the certification. People started using the dashboard because it just flat out did everything for you. Storage services. Cinder's your main one. It's block storage. It can use different drivers. You can tie it in. I think CGIS, is it CGIS that uses Scale.io in their OpenStack? So Cinder, the driver on the backside, talks to the Scale.io device to carve out LUNs for use. It can talk to LVM, it can talk to Ceph, whatever you have. There's a lot of drivers for it. Swift is just like S3. And actually, one of the cool things about Red Hat OpenStack that I like that lately they've been doing is Ceph. Ceph storage will actually pretend to be Swift. It speaks all the Swift APIs and actually S3 APIs too. So your OpenStack thinks it's talking to a Swift, but it's actually just talking to your Ceph. Pretty awesome. Manila is your file systems as a service. So think of NFS or CIFS, and that's another thing that Ceph can do. Plug in Ceph here big time. There's a driver, StephFS, and you can use Manila to actually export NFS and not have to set up a NFS server to manage. Just set up the Manila share, and OpenStack manages the server part and presents you with an NFS mount point. Pretty slick. How do we deploy and operate our OpenStack clouds? The three big ones: OpenStack, Ansible, OOO, and Cola. OOO is what Red Hat uses. We call it Director. The downstream is Director. And basically what it is, OOO is OpenStack on OpenStack. So you have a single node OpenStack install that then uses Ironic, Heat, Nova, Neutron to deploy your overcloud. OOO, the director is called Undercloud. That your end users will actually interface with. OpenStack, Ansible, just what it sounds like. It's a bunch of Ansible roles and plays that you set up your inventory, and it turns that stack of hardware into whatever OpenStack configuration you want. Cola is very similar to OpenStack Ansible in that it uses, I've got it listed as Cola here, but there's actually Cola-Ansible. The big difference between Cola Ansible and OpenStack Ansible, Cola uses containers, starting with OpenStack Platform 13, which was based on Queens. Red Hat moved to using Cola containers. Cola Ansible is a way to use those Cola containers to stand up in your own. It's pretty simple. It's pretty straightforward. It's really I like it a lot. I like OOO a lot too, but for ease of use, Cola takes the cake. That's pretty nice. Here it's this. I'm going to glaze over this a little bit. It seems simple to me, and not saying simple, but it's managing HPC clusters. Get handed a big chunk of hardware all the time, so you like step 1, step 2, step 3. Those are like really simple things, but the amount of work that you put into each of these steps is really, there's a lot, especially in the prepping the network and hardware and stuff. Making sure all your firmware is matching. Basically, you want as close to a homogeneous network or cluster as you can possibly get. You want everything to match, to be the same, so that everything's in a known state. It's really important. That really covers all three of these. Just make your life as easy as possible. Make everything the same. Here's some resources if you want to learn more. Send me a chat, and I'll let you know if there's anything, or give you these. Share the slides too. Any questions before we jump over to the demo? Okay. You guys are still there, right? You're not just all left.
I'm still here.
Okay.
Yeah. I'm not sleeping.
All right. Can you guys see that?
Yes.
Yeah. All right. So this is my local install. I installed using Ansible. I got a single node Intel NUC, 10th gen Intel NUC, i7. I think it's 6 cores and 64 gigs of RAM. All installed on one node. It's really awesome. I've been really happy with it. So this is the dashboard and Horizon, and you can see that when you jump in, you got a nice overview. This is what I'm running. I'm running my local stuff off of here at the house. I got a Pi-hole set up, Unify for my network gear, ROM share. I'm sharing ROMs out to all the Raspberry Pis in my house, so that we can have one place for save games. It's pretty slick. Jumping over to instances, get a nice overview of what's happening. Launching, we'll launch one in a second. Nice breakdown. One of the really nice things. Oh, sorry?
Can you blow it up just a little bit?
Oh, yeah, sure. Sorry. Is that better?
Yeah. Yep.
All right, awesome.
Thanks.
So one of the cool things, yeah, no problem. One of the cool things is you zoom in on an instance, it gives you some breakdown of what's going on. Security groups, just like in AWS, what's allowed to get to the device, what volumes are attached to it, IP address, RAM, all that stuff. The really slick part is the console. So this is an actual console on the system. You can log in like you have physical access. It's really slick. I love it. Get some other nice stuff. Logs here. Here's the log of the system. It reports out. Excuse me. What network interfaces, all that stuff. Up down to images. Images are shared out by glance, like I mentioned earlier. I just threw up my standard, the ones that I tend to use the most in testing. Nothing fancy about these. You can get them directly from, I think, cloud.centos and cloud.ubuntu. Fedora has theirs. Key pairs are your SSH keys for access. Server groups are something that's pretty cool. You can set up, the main use of these is affinity groups and anti-affinity groups, where you have, and in my case, it doesn't make much sense because I have a single node. But if you have for example, an application that you want to have to be highly available, you would set up an anti-affinity rule. That way, if you have 3 web servers, they're not all 3 going to land on the same hypervisor. So that's pretty cool. There, you can do some other stuff with them, but that's the main use for server groups. Volumes, just what they say. These are block device. I'm using LVM as the back end. So I have a 1 terabyte NVMe drive in this thing, and I just made a partition. I think it's like 800 gigs, and turned it into a PV. So, and I pointed sender at that PV and said, here you go, you manage this, it's all yours. So every time I click create volume, it's a default type. Test, I can give it whatever size I want, and hit create, and bam, it gets created. And now I can attach this, attachments, and let's see, what's going to cause the least amount of trouble. We'll attach it to the Unify. So he will go over and attach. Go back up here real fast. We go into Unify, and we look at his console. Oh, maybe not. Show it here. Of course not. But what happened was a VDB device got attached to this guy, and it's hot, it's ready to roll. All I have to do is format it and take off. I can come back down and just do the same thing. Manage connect attachments, detach it, and it's giving you the warning like, hey, wait, you might be using this. You don't care. Okay. But that's volumes. You can make backups of the volumes and snapshots, and manage those however you want. A really cool thing that you can do with snapshots is, let's say that I want to set up another ROM share. I just take a snapshot of that system, and then I can actually boot that snapshot, and it will be an identical, other than MAC address and device IDs, it'll be identical to the current share. Networking. I've got a very simple network. I've only got one, my local network that's in my wireless and on my Ubiquity stuff. You can get really fancy with the networking. We can create a network, and we can call this internal, and it'll ask us to create a subnet. Subnet doesn't matter. Give it a network address. We don't have to give it a gateway IP. It'll automatically assume about 1. And we'll say that we're going to hand out addresses from 50 to 250. And then you can provision name servers. If you don't provision name servers, OpenStack will set up a little name server that'll give you local, like it'll be able to resolve the names of everything in your tenant. And then that will forward out to whatever upstream DNS server that you have, and you can create routes there if you need to. So I've just created, excuse me?
Oh, sorry, Brandon. I was just curious. Does that use a DNS mask to do that, or?
It sure does. Yep. So it abuses DNS mask and network namespaces. So if we were to look into the network container, we would see a namespace, and you could see the gateway would have an interface inside that namespace. The DHCP server would have a name or an IP inside that namespace. It's all virtual. This network is a VXLAN network. It's all controlled by Open vSwitch through Neutron, and it's completely virtual. I can attach it to, I can make a router, router. And we can set the external network as LAN, which is my home network. We'll see it pop in this. Yep. So here, right here, here he is. So now we can add an interface on this router. We're going to do it on the internal subnet. And what we've done here is bridged. We've now bridged these two networks. So anything on this network via the normal routes will be able to talk out to the LAN. They'll be able to pull down IPs. Like, so if you need to, if you want to expose a system on this network to devices on the LAN, you'll get a floating IP and attach it. And I'll walk through that in just a minute. But that's all virtual. Everything is housed inside of Open vSwitch. Let's see, routers, we've covered those. Security groups are just like AWS security groups. You see I've got a bunch set up here. Let's see, an interesting one, SSH ICMP. So by default, the only two rules you have are the top two, the egress, and basically that says, hey, we're going to allow out everything, period. We don't care. But coming in, by default, we allow nothing. So I had to make ingress rules for ICMP, and I said, hey, it's my home network. I trust devices here for the most part. So let's allow ICMP from anywhere into my systems. Same thing for SSH. You can do that. You can define it, go and add custom rules. It's got some defaults built in. Get pretty advanced. One thing that you can also do is create a type of rule. Yeah, here you go. So we can say instead of setting up allow all these things from this CIDR range, let's allow stuff who live in only the HTTP and HTTPS security group. So any hosts that have HTTP and HTTPS security group on them will be able to SSH in or whatever, right? It's very similar to AWS has this type of thing where you can say, hey, anybody on my internal network, we trust them, or anybody with this security group, we trust them. Floating IPs are, if I don't have any right now, but let's allocate one. So I'm just going to grab an IP, and it'll go out and it'll give me this IP. It's not attached to anything, so it's down. I have control of this IP, and I always will unless I release it. So you can manage systems. We did this in previous jobs where we would rebuild the back end, set up a new server to replace the current one, and then just migrate the floating IP over to the new one when we were ready. And we've completely updated the system, but nobody on the front had any idea that anything had changed. All their home, everything was mapped the way it was supposed to. There are admin pages. Admin just gives me a view. If I had more than my tenant set up, you would be able to see it here. You can get in down and see, oh, yep, here's my hypervisors. I only have one. And you can see how much he has consumed. Host aggregates. These are things, host aggregates you can build into Nova scheduling policies. And basically, there's a million different scheduling, they call them filters. You can filter based on RAM or CPU, and basically it says, hey, always give me the hypervisor that has the most available RAM and the most available CPU. You can do advanced things like, well, I know that I have 2 racks of gear, and each rack has a different power source. So I always want to be able to target my virtual machine at one rack or the other so that I can make smart decisions about my HA. So if one rack loses power, well, I was smart and had two hosts set up on each rack, or a host set up on each rack, so that at least one would be on all the time, that sort of thing. Instances, again, if I had more tenants of other stuff, I should have set up something. I didn't think about it, but you would be able to see all the instances here. Flavors, these are you control the size of the VM that gets created. And that's something that's cool too. One thing that's handy is you can resize an instance. Let me see if I can do it from here. Can't do it from here. So I could click resize instance and pick a new instance size. Right now, this one's medium. It's two CPUs, 4 gigs of RAM, and a 10 gig disk. I could resize this instance up to an extra large, and he would get whatever the extra large flavor is, and he would reboot and come back up with that. It's not live; you have to reboot, but he would come back with that flavor instead. So extra large in this case would be 8 CPUs, 16 gigs RAM. Images here these are all the images that all the tenants have uploaded, so you can keep an eye on what people are using. There are policies you can set up, and all of this is just like AWS set up policies to fine-grain control, so you can turn off image uploading so that people can only use images that you approve and you upload, that sort of thing. We've seen all the volume stuff. We've seen all the network stuff. We've seen all the system stuff. All right, cool. So let's go make an instance. So I'll do it through the GUI, and then I'll do it through stop sharing. You guys have to tell me, how bad is this that I'm having the whole thing? Is it really small?
Great for me, but I'm on an ultra wide.
Yeah.
Yeah.
All right. So we'll see what we can do a little bit. All right. Launch instance. We're just going to call this test. The source, we're going to pick, we're going to boot from an image, and for this one, we'll create a new volume. That's fine. We can define the volume size here, but if you don't define it, or if I leave it to 1, what will happen is the system will use what's on the flavor. And by default, I've set all mine to 10 gigs. So let's create a COS 8. Up down to delete the volume on instance delete. Instead of flavor, we'll do a medium. Select our network. We'll try internal. I just set that network up. I expect it to work, but we'll see what happens. And it gives you 2 options. You can say, hey, just spin up on some network, or I can define in advance network port with a specific IP, with specific rules, and have it available here. But since I'm using the network here, I don't have to do that. So I can skip over that one. Security groups, we'll keep it simple. We just want SSH and ICMP. Key pair, since I only have one, it's default selected. Configuration, here's where we can insert user data. So cloud init is in all these images. It will take this script that you provided, and cloud init will run that when the system boots and do whatever configuration you need. Server groups, here's this is the anti-affinity or affinity rules. Scheduler hints, You can give Nova some hints here to say, hey, I want this to live in a specific rack or whatever, that sort of thing, just to give the Nova scheduler some idea of like, hey, I want to try to live here. Metadata, this is information you can pass into the system. I'll show it when we get in. But this is system about, or information about your instance. Played with AWS at all, you should be familiar with that. All right, so he spun up, or spinning up. We see that he got an IP address on that private network, and he is carving out the LVM right now, the logical volume out of LVM. It's going to take him just a minute. While he's doing that, let's hop over to network and see. Yep, there's my guy. There, he's up. He's back here. All right, so he's active now. So I can't. There's no way that I can get to him. I could, if I knew the password. Fedora instance or CentOS doesn't do it either. If they set a root password that was static, I could log in through the console, but they don't. So I need to associate a floating IP with him. Pull one out. .100. So we'll associate .100. Should be. Yep. So I can ping him. So let's log into him. All right, so there he is. So his name is Test, and he got that from the metadata. That's curl built in here. This is the magic metadata URL. If you've ever worked with AWS, you should be familiar with that. So I'm talking to OpenStack here, and this is the data that you can see. So what's my host name? That's test.novalocal. So you can provide metadata to, when you create the instance, to pass in some extra stuff like, hey, here's a URL that you need to go pull your application from, or something like that, right? So that's pretty slick. If we do if config, we see that he thinks that he is only N00116. I can ping out to Google, I hope. Oh no. Yeah, it's my name server. So what's my name server set to? Can I even ping that guy? Yep. So it's probably, this is a misconfiguration on my part. We'll ignore it for right now. But you can see the gist. I'm in a completely isolated network. I have no neighbors. Good to go. Like that. So that's an example of spinning one up via the GUI. We can also do it through command line. OpenStack server create. I'm going to use the Fedora 32 image. I'm going to make him the tiny flavor. Use my SSH key. I'm going to put him on the. This one I won't make in the private LAN. I'll make him in the LAN, which is my local network here at home. And I'm going to attach this security group. I had to use the UID here because I have another tenant I use for OpenShift that has the same SSH plus ICMP, and he complains if I use him by name. Hey, I see multiple of those. You need to tell me which one to use. And this one we'll call something besides test. Let's call him command line. So he takes a second, and there he comes back and spits out some information. I come over here and refresh the page. There he is spinning up, and he landed at 88. So I should be able to. There he is. Uptime. And this guy should have. Of course he doesn't. There we go. point him at my Pi hole, let the Pi hole handle DNS. So there he is. He just got spun up, and let's see, look around. Got a 10 gig disk that was defined by my flavor. That's it. So now we can let's get out of here, do an OpenStack server list, and you'll see all the stuff that I've done. So we've got these. Let's OpenStack server delete command line. Fresh. Gone. Do a server delete on test. Here. There we go. Now, if you remember on test, we defined the volume and we told it to delete. So I should have done this before I deleted them, but there was a volume in here that was 10 that was attached. But since I told it to delete the volume when we deleted the instance, deleted it. We can do network. Oops. OpenStack network list. We see the internal network that we just created today. See my network. Same thing for subnets, all that. And that is my demo. You guys have any questions? Want to see anything in particular? Awesome. You guys are easy. Or I'm talking to myself.
Yeah. Can you open Pi-hole? Let's go take a look at your query log, just so we can see what
sure.
sites you've been visiting. That is pretty cool that you've got one loaded up in there. Right now, I've got one running on a Raspberry Pi and then one in Rev. And the custom script that I had to write to keep them in sync is a pain. Much nicer.
It is very cool. The problem is what happens when that's down, because I'm using Ubiquiti gear right now, and the Ubiquiti is pointing by default systems. I don't know if it's not going to show it here. By default, Ubiquiti hands out the secure gateway as its DHCP or DNS server, and I've configured Ubiquiti to say, hey, forward all your DNS lookups to the Pi-hole. Let him handle it. I also had some nasty tablet stuff going on where if they couldn't talk to ad servers, they would try to open up a direct connection back out to another DNS server and not use mine. So I created a Ubiquiti firewall rule that says, hey, only allow DNS out of my network from the Pi-hole to stop that. And it worked. It's great. The problem came when the power went off and my NUC did not power back up, so Pi-hole's not running. Now nothing on the network. Even though wireless is working, all the network's working fine because Ubiquiti doesn't need to talk to its controller to work. But nothing can talk to anything because it can't look, Pi-hole's not there. So I've got to figure out a way around that. And I'm pretty sure what I'm going to end up doing is putting the Pi-hole software on the USG itself, on the secure gateway itself. But that's not something that I'm looking forward to doing. Yeah, I can imagine what's going to happen. Sorry, go ahead.
I was just going to say, yeah, it's a good idea to, if you could get it running on there, I'd love to see it. I have a Dream machine now, and the UDM box, and it'd be pretty kick-ass if I could get Pi-hole running on that.
Yeah. As soon as I leave the house, I know like the first site visit that I'm going to have to do for one of my customers, the power is going to go out, and my wife is going to call me and screaming because, hey, the internet's down. even though the power's back on. I know that's exactly what's going to happen. And I don't want to try to troubleshoot that over the phone with my wife. That would be fun.
Yeah, that was another thing that I ran into when I was, because I had mine fully virtualized. I had 2 instances, but they were both running on top of Rev. But like you, it's it's an order of operations thing. Rev pretty much needed it in order to run, but it couldn't run because it was on Rev.
Yep, good old chicken and egg.
Yep. So I broke one out into a Pi, or to an actual Pi, and haven't looked back.
Yeah, I've got mine running on Pi Zeros.
You've got it on a Pi Zero? You don't have any issues with it?
Nope.
I
Nice.
always thought that wouldn't be powerful enough. Figured you'd
even over Wi-Fi, it's not even hardline.
Nice.
I've got one for each network.
Cool. If you guys have any questions, shoot me an email, send me a message. I will gladly answer.
All right, man. I really appreciate it.
Yeah.
Yeah, thank you.
For joining.
And look at that. Perfect timing. 1 hour.
Boom.
It's almost like I planned that. Really didn't.
All right, I'll send out invites for whatever we get planned for next month. If anybody's looking to wanting to present, you just let me know, so I don't have to come looking for you. Cool. All right, y'all have a good evening. Thanks.
Yep.
Thanks.
See you guys. Thanks. Yeah, no problem.
Thanks a lot.